Hello, I'm Nick Bergeron, and I'm going to go over what I did for Physics Lab 4. So for Physics Lab 4, what we were doing is that we were calculating the differences in circuits. So we go over a series circuit, a parallel circuit, and an RC circuit. We're going to be using some laws, and we are going to use Kirchhoff's laws that current converse con, that should not say conversations. It should say conservation, but it's that I in is equal to I out in a closed system, which what this circuit is. Your current is only going to be what you put into it. So for this, I did the online I did the online method. So there are no external forces at all acting on these circuits. And also the loop rule that dV is equal to zero, which once again ties into the previous rule. And of course, we're going to be using Ohm's law that V is equal to I times R. So we at first use a series circuit, and the R total is 147 ohms, as we have a 100 ohm resistor and a 47 ohm resistor. So our voltage is equal to I times R total, and our current is equal to 0.0204 amps, which is what we found using our amperes, and then I1 is equal to I2. So as you can see right here, the current represents the positive charge passing through the wire per second, and 3 volts is the potential difference from one end of the circuit to the other. And in this, dV is equal to 0V because each part of the circuit combines to equal dV. So we have BC plus CD plus DE plus EF and so on all combine to equal 0V, as we will see soon. So V of AB is equal to 3 volts since there is no resistance from the wires, since in the simulation it assumes no resistance in the wires. But then once it hits those first two resistors, this is when we find our negative 3V when we combine these two. So everything else, once we get past the resistors, is 0 volts because the wires and the ammeters both are presumed to have zero resistance. So RTV is equal to 0 volts, which stands true. And then for the parallel circuit, we have our current is equal to 0.09 amps. What this is interesting is that the potential difference distributes through the path of least resistance. So the circuits are not going to be going through this path that has the resistor. It is simply going to be going around. So there is one, as I said, one parallel path has no resistance and is always taken. And here is our RC circuit. So we have a 9-volt battery, a 0.2 F capacitor, and we have both a 10 ohm light bulb and a 20 ohm light bulb. And these both take different times to charge because they are one light bulb is twice or has twice as much resistance. And as you can see right here, the discharge time for the 10 ohm was 8.56 seconds, and the discharge for the 20 was 70.32, which means that discharge time is proportional to resistance and is therefore proportional to potential difference, because as resistance increase, so does the difference between your two objects that you're measuring. So this is the calculations that we found to use RC. So in the lab instructions, we were giving these equations. As you can see, this bottom is derived from the top, where we are solving for negative T over RC. So using an Excel sheets, I was able to find a variety of calculations of both time and voltage on a 30 ohm light bulb, which I then used to extrapolate the negative 1 over RC, which is this slope right here. This light blue slope is the path of best fit, and this is our actual. This is what I measured during my calculation. So as we can see right here, negative 1 over RC is equal to negative 0.0792, which means that RC is equal to 12.62. And now, so what ifs if I used a real ammeter? Ammeters have an actual resistance in real life because they interfere with electrons. Obviously, in the simulation, there are none. So the recorded current through an ammeter is actually less than what it actually is. And also, what if I used a real battery? Conductors still have resistance, including the battery and the capacitor. So there would be a slower current just because everything has some kind of resistance. Even the best conductor in the world still has some resistance. So in real life, we would have to keep keep that in mind, which would result in a slower current. And that is all for my Physics 2 Lab 4. Thanks for watching.